So in this problem, we have a circular thin platform of radius r and mass big M. On that disk, on that platform, there is a person standing at the rim. The platform is rotating with some initial angular speed omega. The person then starts to move towards the center. So it gets to a distance of 1.33 meters away from the axis. The question is, what is the angular speed of the platform when the person is here? Well, if you look at the system, there are no external torques acting on the system, which means that if you have external torques equal to 0, then the total angular momentum of the system has to be conserved. So the angular momentum of the system, L initial, is equal to L final. Which also means that I initial, omega initial, is equal to I final, omega final, where I initial is the moment of inertia of the system initially, and I final is the moment of inertia of the entire system in the final state, and the final state when the person is closer to the axis. Omega initial is given, omega final is what we're looking for. So omega final is equal to omega initial, I initial over I final. So in order to find the final angular speed, we need to know the initial and final moments of inertia of the system. So let's start with the initial one. The initial moment of inertia consists of the moment of inertia of the disk with respect to this axis, and this is given. So this is equal to 1 over 2 big M r squared plus the moment of inertia of the person with respect to this axis. Now initially the person is right at the rim of the disk, which means that if you think of the person as a point mass, you have a point mass at the distance r from the axis, so the moment of inertia is equal to simply m r squared, where m is the small m mass of the person. What about the final moment of inertia? I final. In the final state, you also have the disk, so you have 1 over 2 mr squared plus the moment of inertia of the person when the person is now closer to the axis. Let's say that this distance here is equal to r prime. So instead of mr squared, you have mr prime squared. So now we can use that information and plug it in here. So this is equal to omega initial 1 over 2 mr squared plus mr squared over 1 over 2 mr squared plus mr prime squared. You can simplify this. Let's divide the numerator and the denominator by mr squared. Big M r squared. So you have omega initial 1 over 2 plus m over m 1 over 2 plus m over big M r prime over r squared. Now you can also get rid of the 1 over 2's. So this will give you omega initial plus 1, 2m over m, 1 plus 2m over m, r prime over r squared. The reason why this form is preferable is that this part and this part are dimensionless. So when you put the numbers in, the value that you get is 1.80 radians per second. You are given the initial velocity, mass of the person, mass of the disk, radius of the disk, and the final distance of the person from the axis. So all the information is given, you just calculate for omega final to be 1.8 radians per second.